Okay, no problem. So we were here. Okay, so these all things are done already. I told you guys to prepare the checklist according to you, but no one has done it. So I will see by when we can receive it. Here also we have seen up to here. Now this was the topic we were supposed to start. Okay, so golden rules of coordination. So before we start learning about the coordination of the services inside the building, first we need to understand that what are the services and how does it work. Okay, so inside the services, first thing it comes to fire and life safety. Okay, so today we'll try to understand what is a fire system and how does it work in a building. Okay, so fire system is nothing but to save the life of people in case of fire. Okay, if the fire happens in a building, then in that situation there are multiple systems which is already pre-built in the building so that the people can be rescued, before it harm, like they are harmed by the fire. So the normally sprinkler systems are there, different kind of systems are there in the building, which works in another different kind of a strategy with, but the most common system which we deal with while doing the coordination in the for the services in the building. So that's why we'll see, overall if you'll go deep to learn these things, design and all, it will take a longer time, like that is a complete separate discussion or a subject to learn. But here we will learn from the high level. Okay, like a brief of it, the service, how does it work, what is the purpose, and how to how does it work like normally, and what are the equipments and the accessories comes in between, what are the uses of those. Okay, so normally fire protection system in a building we are going to learn as a fire hose reel system plus a sprinkler system. Okay, so and then another system is there, we call it hydrant system. Okay, so basically to protect life and items, like the asset of the building, we use the fire protection system in a building. So in that, this complete system is consist of multiple items, but those three items are very important for us, because with that only we used to deal while doing the coordination. Okay, so first is hydrant system, and then hose reel systems, and then sprinkler system. Okay, so before we know that how to coordinate it, let's understand what this system is and what is the how does it work. Okay, so basically it is a system which delivers water for suppressing the fire. Okay, now how does this complete configuration works, that we will see here. Okay, so basically we have a tank where we store the water. Okay, and from the store we connect a pump, multiple kinds of pumps. Okay, and those are then distributing the water in the building so that we can suppress the fire in the different scenarios. Okay, so we'll start from here, from tank, then we'll go further, like by the line. Okay, so we have the tank here, and then the municipalities have the guidelines for how long water should be kept there. Okay, so based on the design, you will find the size, what size of the water tank is required. Suppose some municipality they are saying that 1 hour protection should be there, then 1 hour. If this pump is running on the full capacity, then it should maintain it, at least it should run for an hour, before the water is finished. Okay, why we keep it that way? Because by that time the fire brigade system, the fire protection system of that city can come, and then they can start doing the rescue process. Okay, so minimum 1 hour, let's say, you have to design for your project. Okay, so for that we have the tank. Okay, this tank sizing you will get from the engineer who is doing the design engineering. Okay, then from there, normally your work is to model this and coordinate this in the building as a BIM coordinator. Okay, so now see this, the tanks are connected with these two lines. Sorry, the first of all the tank should be partitioned in two parts. Okay, so every tank of the fire should have a partition. Okay, half water here and half water here. So it should be partitioned with the two partitions. Okay, and those partitions should be separate, because in the case of suppose any repairing or any maintenance in one tank, the another is ready with the water. Okay, so anytime we cannot take risk of emptying all the tanks at the same time and doing the maintenance. Okay, so that's why we have to have partition of the your tank. Okay, so that you can close the equalizer line in between, and then you can maintain the one tank, and then another you can keep it ready. Okay, so basically we will take a pipe from the each tank. Okay, so one from this and one from this, and we'll make one header line, and that header will come out with one isolation valve. Okay, this isolation valve will put, and so basically it is shown here, but if you are taking two connections, then uh, provide the isolation valve with each connection. Okay, so one here also and one here also, not together here. Okay, so in that case what will happen, one you can close and one you can maintain, and one you can close and one you can open, and then you can have the maintenance process, and also the ready water for your pumps. Okay, so this is that valve. Okay, so this is isolation valve. Isolation valve, you can use the gate valves or what do you call, butterfly valves as per the applications. Okay, so in fire system mostly they are using the OS and Y type gate valve. Okay, so let's say that valve is this one. Then it goes to the header. Okay, then header, from the header these three pumps are connected. Okay, again the sizing of this will be given by your fire protection engineer, and there is a rule book for this one, how to size this, and that complete subject is design subject. If you'll go deep into that, then it will be a very long course, so that I'll leave apart. You think that you will get these calculations ready made. Okay, so you got the size of the header. Okay, obviously it will be bigger than this now, connection pipes. Then you will be getting three kinds of pumps. Okay, first is electrical pump, then jockey pump, and then diesel pump. Okay, so electrical pump and jockey pump and diesel pump. So basically what happens, this complete system after the pump, whatever connected to the building lines, it has to be filled with the water 24/7. It should be always ready with the water. Okay, because you cannot know that when the fire can happen in the building. So suppose this complete system is filled with water. That water, it cannot be only water. It has to be a pressurized water. Okay, so all these lines are always pressurized with water. Okay, and in some cases there is no water, that is a separate system. Okay, so don't mix it here. I'm talking about the 80% of the places what we deal in here in UAE and Asia. Like if it's not freezing country like you can US, then this is the system we are working mostly. Okay, so in that ready-made water is always there. So uh, these waters are pressurized water. Okay, and it has to be minimum at 6.9 bar pressurized bar. Okay, so it cannot be less than that. That is the rule. So suppose if your this one the line is coming down from that, the pressure is going down of that one, then your system should run again, this pump should run to maintain the pressure of the water inside these lines. Okay, so normally if electrical pumps are powerful and big in size, so once it will run, it has a limited capacity which it cannot deliver the water less than its capacity, like minimum capacity. So for that purpose, to keep pressure in the line always on an optimum level or the minimum level, above a minimum level, let's say it's in two scenarios there. One scenario is 6.9, another is 10. Okay, so 10 bar or 6.9 bar, whatever your project design specifications are there. So you have to always maintain that water. So whenever for any reason, if the leakage is happening and is broken or any drain has happened, whatever reasons, if for any reason the water is drained and the pressure is low, then directly this pump will be activated, and it will start delivering the water in the system slowly, and it will maintain the pressure in the line. Okay, which should be not less than 6.9 bar at any case. Okay, and how does it happen? There is no man required to do that. So it's completely controlled by electromechanical system, like control systems. Okay, so there is pressure gauge which is connected with the your line. Okay, so a sensing line, and those are connected with the control panel. So as quick as this pressure is dropped, this sensor gets the signal that the pressure is now less than 6.9 bar, then that it gives the signal, and then this goes to this panel, and then panel gives the signal to the pump to operate and maintain the water pressure back to 6.9, right? So it maintains the water in the system always 6.9. Suppose if it's normal, like very auxiliary kind of case and very less water leakage is happened, then what happens, this water will go and it will just compensate the pressure, and as quick as it's maintaining the pressure, it will automatically, the pump will stop. Okay, so now if that was the case of any maintenance issue or any leakage issue, then it will be fulfilled. But suppose actual fire is happening and somewhere the sprinklers are activating and the continuously it's discharging the water, or your fire hose reel is working, someone is operating it. So in that case also, if it continuously it is taking water, and this pump is not very powerful pump, so as I told you, it's a mean like it delivers less water. Okay, so it has some certain capacity, on that only it can deliver. So if continuously it's running and it cannot maintain the pressure and the pressure drop is increasing with the time, then what will happen, then this electrical pump will start, this will trigger. Okay, so these all things are programmed in such a way that it will work back to back. Okay, so electrical pump will start and then it will start with the bigger capacity than this jockey pump, so it can maintain the pressure as well as. So what it means, once electrical pump is starting, it means the real fire is there somewhere. Okay, and more water demands are there, that's why this pressure is not able to, like jockey pump is not able to maintain the pressure of the line, so that's why electrical pump is started now. After that, so electrical pump will take care of all the demands and it can maintain the pressure as well as the flow rate. Okay, then suppose because of fire your wire is burn out, or these both pumps are electrical pumps, so both are not able to work. In that case you will have another pump of the same capacity of the electrical pump, diesel pump. Okay, so this will start with the diesel engine is there, and then it will start working on the diesel, so it does not require any electricity. So even if the wires are burnt and this control system and these all things are not working, the diesel pump can work and then it can deliver the water. So it's like two times protection. Okay, so that's why these all lines are there. Now here you see, so normally how the equipments are connected, this is important. Okay, so when you're doing the coordination, so these all systems comes in a room, we call it fire pump room. Okay, so when you are coordinating the fire pump room, you need to master these all equipments, how does the connection happens. Okay, so basically these three pumps will always come in the fire pump room. Okay, it has to be there. Okay, so your mind, you need to keep that what room I'm coordinating. So is it fire pump room, then automatically it should trigger to your mind that here three pumps should come. Okay, so first thing what you'll do, you look the submittals of these three pumps. Okay, if you are on the construction stage, unless you are in design stage, then you can give the generic families. But if you are in the construction phase LOD 400, then you have to have these pumps, you know submittal means the actual data of the manufacturer, which kind of pump they are going to use, and all the datas are there in the, like that is technical data set, like a catalog of that item. Okay, so that is given. So from there you can know the height, weight, the line, the size, the discharge, everything you will get it in that submittal. So first thing you need to find the submittal of these three equipments must. Okay, then if you are on the design, then you have the generic family, that also you can use, but these three, all three are different. Like, but at least you can decide that this is diesel, this is electrical pump, and this is jockey pump, which is smaller, this is bigger, and this is far bigger. Okay, now then this connection, what is happening, that is important to know. Okay, so first all of these pumps we are connecting with a single header. Why? Because in any case any one of these pumps can run at any time. Okay, so these pumps can run at any time, anyone. So that's why, suppose independently means, suppose I want only to run the jockey pump, then it can take the water from the same tank, because the header is same, and then it can run, and these two can rest. Okay, but suppose I want these both pump to run, these both can run from the, and they can take the water from the same. Then suppose these both are closed and I want to run this, then that also can say take the water from the same system and it can deliver. Okay, so basically if two are not working, or one is working, or one is only one is working, whatever conditions are there, we have to have arrangement in such a way that all can take the water at the same time. Okay, so here from header we will connect all these lines, pumps. Okay, so now what did you learn? If I am doing the fire service, I will start from the fire pump room. Okay, then from the fire pump room, first I will check whether the water tank is there in the room or not. Okay, then you will just verify with the sizing of the water tank. So sizing, suppose 1 cubic meter means 1000 liters water will come. Okay, so they will give you the 1000 liters of water, like capacity in 1000 liters. For example, here they have given in gallons, so you'll know the capacity of that water tank, and then you can calculate the volume of that what do you call that tank, and then you can check whether um, this tank is enough or not. In that there is a rule. Okay, so what you have to do, 10% below 10% volume you will leave at the down as a extra, like what do you call as a extra water you are keeping in the bottom. Okay, which you are thinking that you cannot use it. Okay, so that is at the bottom you will keep that one. Okay, that much percentage. Then on the 10% above also you will keep as a freeboard area, so because you don't want to fill the water till the neck of the complete tank. So actually, so what you are doing, 10% below extra you are keeping, and 10% above extra space you are leaving. Okay, so these two things you keep in mind. After that, whatever the volume is coming, that is the water volume of your. So suppose if they have given 75,000 liters, then even 75,000 plus 20% should be the volume of your water tank. So you learned one thing. Okay, then you are coming from this line. Okay, this line sizing you will get it. Okay, then after that you have to check that when the tapping is coming out, quick immediately after that, from the each tank connection you have to have a IV. If it is not there, means it you are doing wrong. Okay, so you have to give the IV. IV means isolation valve. Then after that you will go to the header, and then from header you will get three kinds of pumps. Okay, so you need to check that all these three pumps are available or not. Okay, then this pump to this header, the connection length should be minimum 1200 mm. Okay, so try to maintain, not try, but it is must, like you need to keep that 1.2 meter away. This pump from this header you need to keep 1.2 meter away. Now we will not go into depth why this required and technical, just you understand that it is required. Okay, minimum requirement as a coordinator, that's what you need to know. Okay, then first time to isolate like each pumps, then it has to work independently. So each has to have one isolation valve. Okay, so one isolation valve here, one isolation, and one isolation here, right? So each has the isolation valve, and then it has a pressure gauge, and that also pressure gauge is connected with one isolation valve. So anytime if you want to repair, you can close this and you can repair or change or whatever you want. Okay, so the isolation valve means we can isolate this system in case of any maintenance. So suppose here up to here our water is ready, we want to maintain this engine. So what we can do, we can close this valve and then we can maintain, and the water will not go inside this. Okay, but these other pumps are ready that time. Okay, these are open and these are ready. The same case, if this is ready, we can keep it open, and this we can close and we can repair. Okay, so from this side water is always ready, so it after dismantling this pump the water should not keep flowing. That's why we will keep here one valve so that it can disconnect the system from the header. Okay, so this is the reason you have to check first thing, if the pumps are connected, are these pumps connected in parallel sequence. Parallel means from same header all these are connected, and each connection has to be given with one isolation valve. Okay, so this is simple rule. Okay, if any of these connections are not given in that way, it means there is something wrong. Okay, so this is the way to verify the systems quickly. Like as a coordinator you need to know that all the systems are working correctly or no. All or my modelers, the team members to whom I have given this work to do, whether they have done it correctly or not. So very quickly you can verify the complete system, because these are pretty much fixed. Engineering is not like it's not going to change drastically project to project. Once you know the rules, very quickly you can check these systems whether the juniors have done it correctly or not. So this is the one. So suppose they have done a connection where the pump is here and they without IV they have directly connected. So quickly you can give comment, please provide the isolation valve in all the lines. Okay. Or if they have keep this header very close to the pump, then you can say that please provide 1.2 mm distance from this pump. Okay. Then if you are at the soft drawing stage or construction stage, you need to verify the length and width of this pump. Okay. Pump, so how much space it really takes, right? In terms of, so from catalog you'll find out the actual dimension of these pumps, then you will check it. So of course this is a schematic you will do on the floor plan, so you need to see that how long it is taking. Okay. Then another pressure gauge is there after the pump, one pressure gauge before the pump, one pressure gauge after the pump. Okay. Then comes one non-return valve. Anyone? Hello? Yes, yes. Yeah.
Sir, strainer will not be there in the supply side.
Sorry?
Strainer will not be there in the supply side before the
Strainer,
pump.
no, strainer in the fire they don't keep it because it's not regularly running system. Okay. So and it's when it takes the strainer, what does it do? It can it strainer what it filters the water. Okay.
Yes, sir.
It filters the
It
water
filters.
to deliver that one. So basically in the domestic we use it, but in the fire we don't require it. Okay. And if you require
Okay.
it on the high pressure, this pumps when it operates in very high speed, like so very large demand. So that time your strainer will give lot of friction to system. So normally they don't keep it. Okay.
Okay.
So
Okay, sir.
so strainer will be not there. Okay. So isolation valve, and then actually if you want to keep, you can keep it, but that strainer is very different, like basket strainer type of big strainer you have to keep, and it takes space. And actually the codes doesn't say that to use or not use, so that's why the people don't use. Okay. So that's why they have not used it here, but domestic it is must, because domestic water is for regular use. Then this water is going to suppress the water, so here cleanliness of the water is not as much as compulsory like domestic water. Okay. So you have to understand that. Then
Yes, sir. Yes, sir.
so and that also it works 1 hour in maybe 20 years 10 years of time, one time fire happens or no happens, don't know. So it runs on a probability basis which is very less likely to happen, right? So and that also for only 1 hour, so for that we don't take that precaution. Okay. So simple. Okay, after then we provide the NRV. So any pump anywhere when we are putting, we are protecting that pump from the NRV. NRV means non-return valve. So what does it do? It after pump is delivering the water in this line, the water cannot come from this side. It can go only from this direction to this direction. But if the water want to come back from this direction to this direction, then this valve will close it. It will not allow to come. So this is why we call it non-return. It cannot return. It will not allow to return, or we call it check valve. So check valve means it will allow from the flow to happen from the one direction to straight in forward direction. It cannot allow from the back direction. So check valve or NRB is the same thing. So always after the pump we keep it, because we want to protect the pump. So what happens when the pump is running mode, it is forcing water to go this side. But once the pump is closed, the water comes back, because you remember you have to maintain the pressure in this line. So once pressure is done and this pump is closed, then this water, if it is pressurized, it will tend to come backside. And once it will come backside, it will start rotating the pump in opposite direction. Okay, and it will lose the pressure. Also, it will rotate the pump in the different direction. It will harm the pump mechanically. Okay. So basically we want to stop this here. So that's why always NRB will provide in the front side of the pump, so that we can protect the equipment and we can keep the pressure inside the line. Simple. So if any pump is connected without NRB, then you are immediately you can give the comment your system is not correct. The NRBs are missing here. Okay. Then it goes these all lines after the NRB, only this pressure sensing line. This line we call it pressure sensing line, which is a small line, a small pipeline which goes to the pressure sensor here, which is kept in the your control panel. Okay. So control panel is a equipment where mechanical electrical both connections are there inside one box, one panel. And from there it works like in, what you can say that electromagnetically, like both. It's a combination of mechanical and electrical services, like systems. So electromechanical system you can say. So basically once this line is delivering the water, so the pressure in this line after the NRB is the same pressure in this line, and this pressure is giving here the signal to the sensor. The sensor is activating or deactivating the electrical switch, okay, whether this pump should run or not run. Okay, so that's how it works. So this is the pressure sensing line. Now, so NRV use understood. So very quickly we learned that the system, each system has to be in the parallel connection. Each system has to, each pump has to connected with the your first it should be with the isolation valve. Okay, then the other pipe accessories, like the what do you call, pressure gauges. Okay, then pumps. And pumps, whenever it connects, normally manufacturer they recommend to connect with the flexible connectors. Okay, so but in again the fire case, it runs a flexible connector. Why? That once the pump will run, then it will not transfer the vibration of the pump to the pipe. Because if it will keep transferring the vibration to the pipe pressure is your pipe is connected to the tank, then it will vibrate everything, and then leakage will start happening. Okay, so it will break and wear and tear over the time. So that's why the good practice is not to transfer the vibration of equipment to the piping system. Okay, so that's why we always disconnect that with that any moving item. If we have the fan, FCU, pump, whatever, any moving item, we normally should disconnect with it with the system line. If it's directly connected with the duct or pipe or whatever, in between we'll keep a flexible connector. So flexible connector, what it will do, it will work as a shock absorber, like a shocker of your car. So it will not allow the vibration to transfer in the pipeline, right? So that we keep it by. Again, here they have not shown it, but normally it comes here. Okay, if in some cases, like for example, fire pump directly also they connect without flexible connector also, because again the same principle, it does not work always. So for half an hour it's okay, it can tolerate the vibration and all. So that is it. Okay, so that you have to check. Then you go forward, then an RB must be there, then you come again, and then there is a line called test line. Okay, test line. So what is test line? Test line is from the these lines, these pump lines, one line will go back to the tank. So what it will do, suppose anytime you want to test the pump whether it's working or not, then you can close these valves, these isolation valves. So suppose this pump is pumping water. Okay, pumping water, but this pumping water you want to check only, you want to check whether it's delivering the, let's say you need the 500 GPM of water. Okay, so whether my pump is pumping the 500 GPM or not, you cannot break the sprinkler and put the actual fire case and then only you can test, right? That is a horrible way to test it. So what we can do, we can close this valve here, and then we can operate this pump manually, and then we will open this line, we can open, and then we can keep this pipe back to the tank. So basically what it will happen, it will run, it will circulate the water, it will take the water and it will recirculate back to the tank. In between we can check whether this pump is giving the correct discharge or not, the flow required or not. Okay, so when it's happening, so in this test line, what is mandatory to have is this line has to have minimum the flow meter. Okay, so first thing, what did you extra learn here? You learn that in the fire pump room system there is a line called test line. So you'll check whether the test line is there or not, they have modeled it or not. Okay, then after modeling whether they have connected, and now see test line, it's when it's connected, see separately it's connected for jockey and electrical pump. Okay, sorry, not jockey, the electrical pump and the diesel pump. Okay, these two are compulsory to connect. So because these are the one powerful pumps. Okay, those who, this is to only maintain the pressure. So there is no big GPM requirement here, but this pump has to be has to have GPM requirement. Okay, so GPM means I will explain you later on the design stages if I'll teach this one. So for example, if one hydrant system is operating. Okay, so one hydrant system has to have 250 GPM. So two hydrants are operating at the same time. If our design is saying that two hydrants should operate at the same time, then your pump size should be minimum 500 GPM. Okay, so 500 gallon per minute it should pump the water. Okay, so suppose 500 GPM it's what pumping, then our flow meter should give a reading of 500 GPM. Okay, so that's why we need to have a test line and then flow meter. Okay, then it has to, flow meter always has to connect with back and forth gate valves or isolation valve, whatever you call it. So basically same thing. So isolation means isolating the system. Okay, normally the gate valve is a type of valve which can be gate valve, butterfly valve, whatever you want to use, you can use it. Okay. So what normally they do, FM always, flow meter always comes with back and forth this isolation valve. Why? For any maintenance of flow meter, you need to disconnect this system from the, this line. So that's why both side you need the gate valve. Simple. Okay. So in FM, so what you will check, whether these pumps are connected with the test line or not. Then test line, in the test line flow meter is there or not. Okay, and if flow meter is there, then back and forth this isolation valves are given or not. Okay, and then that way you can check that whether this system is correct or not. So anything is, if it's missing, then it's missing, like you need to have a check. Okay, now whenever flow meter you connect, so minimum, like it depends on the manufacturer, but normally it has to have in the complete straight line, because if turbulence and turbulence flow is there, turbulence and laminar flows are there, right? Maybe you have studied in the hydraulics. So the water should flow in the steady way, then only it can measure correctly the reading. Okay, so what, that's why we don't want to have any bend, like immediately. So what is the rule? Five times of your diameter of your pipe back and 3 times of diameters of pipe to the front. That much straight length of pipe should be there without any obstruction or any, straight length means there should not be a bend T45, nothing like that. Okay, so flow meter if you're keeping, you keep, so suppose it's a 100 diameter pipe connection, like 150. So how far it should be from the this gate valve, Ashish?
500, 500 mm.
How?
Sir, five times of the diameter in
Diameter
the
is,
front.
diameter is 150.
150.
Yeah.
Okay, okay. So it would be 750.
Yes, so it should be minimum is 750 away from the first bend or any obstructions, gate valve or whatever is there. Okay, then this one can be 300, like 3 times, so 450 away from there, right?
450.
So yes, so like that, so this you will check. Okay, see these things, if you'll check this, and how many times you have to do it? One time, right? In a project, this pump room is coming one time. So if you do it correctly one time, maybe even it can take one day. Now you are completely satisfied that my fire pump rules is at least systematically it's correct. So again, I don't have to do the rework on this system, right? So that's how you check the system confidently if you are working like coordinator. Then so suppose you have 10 rooms to check, mechanical rooms which are more difficult, right? Or electrical rooms. So now you had the checklist. Okay, so AHU room, fire pump room, chill water, like ETS room, or your whatever, chiller room, whatever rooms are there. So out of that, at least you now know how to check the one room, right? So fire pump room, now it took you maybe 1 2 hours, right? But if 2 hours time, if you'll give it thoroughly, then you can tick that parameter on. Okay, my fire checklist is done, my fire pump room is completely correct. Now you are in the peace of mind that anytime I will not get a rework on this fire pump room, right? I can produce the drawings and I can send to the site, which will work. They will not give the comment back. My drawings will, the chances of drawing rejection will be less. Okay, if the even the drawing rejection will come, it will be not a major comment, because major points I already have covered, or because of the comments from the consultant, I don't have to reconfigure my systems, right? So that's how bring the clarity to the process. Okay, so but these things, these works are done by your juniors, your modelers, and they are not aware of these systems. So what you need to do, you need to instruct them, brief them when they start the work. So suppose 1 or 2% of your team members, they are going to work on the fire pump room, then you take your 15 minutes, half an hour, okay, and then explain them that what kind of the pump room you want, expect from them, what is the minimum maximum requirement of this fire pump room. Okay, and how these systems are working, why it's working, and where we are keeping, why we are keeping. Okay, these things if you give them, then it will give them clarity. Okay, so that's how you need to understand the systems of the buildings, all the systems by yourself. First you will understand, then only you can explain to your team members, and then they can do the work in one time correct. Like when they are doing the modeling first time itself, they will do it correct. Otherwise what will happen, and not will happen, it always happens in the most of the cases. So these modelers who are doing this modeling, they are not well enough aware of these all system. So they will keep this here very near. They will not keep the systems with the correct family. They will use the generic one, and then they will arrange it in the very tiny space, and it looks very fine. According to them, the connections are done, everything is working. Okay, the pipe sizes are correct. But when this drawing goes to the consultant, they return you the drawings with a lot of very tedious comments, like it will exhaust you to do that. And then you come back, then they tell that maintain this distance, keep the distance between the pump, put the actual GA of the pump. Okay, provide the test line is missing. Okay, this provide this flow meter 5 diameter here there. Okay, so what it happens, it basically becomes a new design for you. It now if you are going to work, it's not a comment to implement on the model, but it's a completely whole new work for you. So it's like you are designing from scratch again the complete plant room. You understand? Only because you was not aware at the first time itself that my plant room should be this much systematically done, right? So what will happen? You will assign the person again, right? And then again he will take the same time or even more time, okay, to redesign or reconfigure these items, and then prepare and when he will start doing this shuffling of the system and here and there, what will happen? Your annotation, the sheet presentation of your model goes out. Then again he will first rearrange the system, and then he will rearrange the sheet, and then only he can submit it again, right? Which will cost you 2 times more time than normally how much it should take. And that's where the BIM coordinators goes wrong. If they don't do this task, they have to suffer this way. So it makes sense, guys?
Yes, sir.
Okay,
Sir, there would not be any drain line, sir.
sorry, for where?
There would not be any drain line.
No, pump drain line will be there. Drain line will be there. I will come. So but that they have shown in the drainage drawing, not here. Okay, so once you will go to check the drainage drawing, then you will see it, because that drain line connects with the drain point, so it will be not shown here. Okay, then so let's
Sir,
finish this pumping. Yeah,
there would be a bypass line also,
for what?
like in between the tanks, or like
Yeah, bypass line. Then no, we call it
equalizer
equalizer
line
line.
between it.
Equalizer line. Yeah, there should be a equalizer line in the both tanks. Okay, so again that is not here given. Maybe what they do is they give in the in between that. Normally what should happen? It should be connected with the equalizer line with one isolation valve. So anytime you can disconnect and you can again, because suppose if you're repairing this one, then this water should not flow in that one. Okay, so that way. Another way
Yes,
is
sir. And
suppose
sir,
you have the connections, like the filling line is two different lines, then that is not required. No, so you can fill this and you can, so for example here they have given two filling lines, right? So
yes, sir.
by that they have made sure that this line is filled. Okay, so if only one filling line is there, then that is compulsory. If the two filling lines are there, then not compulsory. Here the filling line itself they have split it. Okay.
Okay.
Uh,
Yes, sir.
so now
Sir, and this tank will be like it is basically a concrete tank, so like it will be designed by the structure team and all, correct, sir?
no, it will be sizing will be given by your design team. What do you call, your fire specialist designer will do. Even I have the calculation, I can explain you separately once you need it. So it's not very big deal calculation. Okay, big depends. Only thing is criteria are different. What kind of building is that, how long you have to protect, where it situates, like which city. Okay, then according to you, according to that you will select the running hours, how much is it required to run. Then based on that, then you have to see that my pump for how much system, how much load is that, like is it designed only for hydrants, is it designed for both hydrant and sprinkler. Okay, according to that you will calculate the demand. Okay, so let's say for two worst case scenario, you always consider that your two hydrants are running which are 500 GPM, okay, and one sprinkler let's say is running. So let's say 750 GPM pump sizes you need. Then 750 GPM pump, if it's working for 1 hour, then how much water it requires? Simple calculation, right? GPM means per minute, right? So it is, let's say 500 GPM is per minute. It means if you multiply with 60, 30,000
60,
gallons of water it
30,000.
requires, right? So that's how you calculate the size.
Yes.
Size,
Each
no,
each
that,
tank is
the,
30,000.
that now you got the size of how much? No, no, each, no, not each, okay? Both are normally connected, maintenance. This is the total tank size. You got it? This partition is
Okay,
only
sir.
for the backup purpose. Understand? It's not
Okay.
like a complete standby and duty. Okay, so that way you will
Yes.
do it. Then, so what I was explaining? Um,
30,000, sir. Like the
so
how to
the
calculate the
so
volume.
30,000 gallons you got it. Now you can convert in liters. Okay, and then you will one, suppose this water this height of this tank is, you can decide by that, and then width of that one, length of that one, and then if you multiply height, width and length, then it will give you the volume, right? And
Yes, sir.
volume means whatever volume, suppose 10 meter cube you are getting, it means 10,000 liters, right? Because 1 meter
Yes, sir.
cubic, 1 cubic meter means 1000 liter it will come, right? So that
Yes.
way you can very quickly check that my tank is enough or not. Okay, if tank is small, then you can highlight them back. Okay, now the structural part, what they do, once you give the sizing, then they do the like how much strength they require, what kind of layering they will do. They will start with the rubble soling, then they will do PCCs, RCCs, like a lot of things they do it. So that is their part. Okay, so that they will
At
take care,
bottom,
that
yeah,
take
at
that take
bottom
care
also
of.
they will place some
uh,
like
some
arrangements here.
sump they could
Yeah, yeah.
keep it to while cleaning it. But normally now what they are doing, they are not making this kind of expensive concrete. They are using the GRP tanks, okay, which comes ready made. They keep it on the plinth, so it's not that complicated. Okay, mostly these
And,
tanks,
and
concrete tanks, where they are using, when the both tanks, domestic and fire, they are using as a combine. Yeah, tell me.
yes. Sir, is there any NFPA rule to keep it over like I can keep it over right tank like on the roof of my building, or I can keep it in the ground. Is there any criteria or NFP standard is there, or
No,
it,
no, no.
it
No, no.
totally depends like
There is,
based on the
say, the
design?
code says that you can have the tank wherever you want.
Design.
Okay, but the fire tank
Okay.
should be in the proximity with the fire pump room. Okay, so it should not be 15-meter away from the fire pumps. Okay, your fire pumps, this tank. Okay, so of course you cannot keep
Mhm.
on the roof. Okay, now for India the code is different. India tells, in Indian fire code system, like fire life safety, they tell you that you have to keep bottom, like ground tank, also you have to keep a supportive tank at the roof. Okay, so there's a room like 25 or 30% of this tank. Okay, that much, you suppose if this is 30,000 gallons, then maybe 500 or 1000 gallon you have to keep on the rooftop as a backup. Okay, but that is only for the Indian standard. Okay, for NFPA and for UAE, that rule is not applied. Okay, so here only ground tank is enough. Okay, why they
Because
keep it? Because
when they mix both,
hmm.
when they mix the like normal water tank plus this fire tank, they are like overhead tanks only, because it will help like through gravity, like the pressure and all.
No, no. The problem is the firefighting system is not that active in the country. Like here Dubai, if any fire happens, within 10 minutes, they will reach from anywhere with the multiple vehicles. They can suppress it very quickly, right? But India, it's not like the cities are. The country itself is very big. The towns are away. The fire brigades are not that many in the numbers. The love. So there will be a reason, okay, why they are keeping it. But those tanks are supportive tanks. So suppose if the water is not here or not choked up or anything, so in that backup case that will work. Okay, so that's why they want you to keep one tank on the roof. Okay, and that is in India. So, but here it's not required. Okay, is it clear? Like
Okay.
in UAE, you will not find it. Okay, because it's not. And in any country, if they are using NFPA standard to design the things, they will not use it because in that they have not considered it. Okay, so that is it. Now, then you come another line, you find it. Diesel pump always connects with one PRV, pressure relief valve. Okay, and that goes back to the your tank again. Okay, so PRV, why? Because diesel pump when it runs on the fire, 1 RPM, and that is on the full capacity. So suppose it will create here this it will create the 12 bar pressure, and the system require only 8 bar or 10 bar. Then 2 bar extra pressure, yeah, it has to release on the back in the tank. Okay, electrical can run on the multiple RPMs, but the diesel will, once it will start on a full capacity. Okay, so that's why if the extra pressure is going generating in the system, so it will harm the system, so better to remove that. So that's why it will have a pressure relief line. Okay, and that will be coupled with the PRB valve, and it will go back to the system. So what it will do, it will deliver whatever the water is required to go into the system, and then rest of the water it will deliver back to the tank. Okay, so now generator, I'm telling the diesel pump line always should connect with one pressure relief line. So if this is missing, you need to check that whether why it's missing and they have considered or not. Okay, so today you will learn about the fire pump room. Okay, so see in very small area how many checklist you find it, and if you explain to your juniors, your team members who are working on this room upfront, then they can save lot of time, you know. So one time if you'll explain them, they can do the work perfectly. And if they are continuous, like you are getting continuous projects, so if you're explaining them one time, then maybe they are doing 2 3 4 projects, whatever projects, again and again you don't have to explain. So that's how you need to be aware of the system before you know the coordination. Make sense? Yeah.
Yes, sir.
Okay.
Yes.
Now, so this was about the pump room. We'll continue now next day, next session about the other part of this. Okay. So we'll learn that how these systems are working and how it is distributed, and then same way we will learn all the systems of the building first, principally how it works and why these things are there and what is the use. Then we will take actual scenario from these models or drawings. Okay, and then we'll try to coordinate the systems in the dimension wise. But before that, you need to
Yes.
understand the system, how it works and what are the criterias. Okay.
Sir, I have a
Yeah.
question, sir.
Hmm.
So, like as you said, like if one this FHC fire hose cabinet,
Hmm.
it or like it's a fire hydrant operates, it need like 250 GPM of water.
Hmm.
So let's say on this project, like what you have just opened, we have multiple, like we could have like 10 or more FHC. So when they will design, they will consider like everything would be open, then what would be the GPM, or they will consider an ideal scenario where like two or three units open, or like how they will.
No, when the fire system designer is designing the fire system, they are considering one fire at one place. They cannot consider that everything is operating at the same time. So what they, and these fire sprinkler systems are designed to just command the fire for some certain time. It is not meant to suppress the fire completely. Understand?
So,
It is not to
understood.
eliminate the fire
Understood.
completely. The elimination of the fire is the duty of the fireman's manually. It cannot be done automatically. Okay, because fire is very in predictable manner, it flashes from here to there. So while designing, so this is only controlling, it's restricting that fire. Okay, this system if I'm installing, at least for 1 hour it will stop to not spread the fire from that zone, right? And then by that time my team will arrive, the firemen, and then they can protect, they can take care from there, right? So in that case they consider
Yes, sir.
that fire always happens one time at one place.
One June.
Okay, one
Okay.
place at one time. So on that basis, but this design criteria little bit more they use it. Okay, so how they use it? So for example, if a hydrant system, so that's why I'm telling you that once I'll explain you that it will become clear for you in the
Oh,
next session. But
okay.
normally what I'm saying is,
Okay.
so but if you have asked, then I'm just explaining you quickly. Okay, so when suppose at any floor fire is happening, they consider that the fire hydrant of that floor will open. Okay, which should be within the 6 meter proximity of your staircase. Okay, so it should not be 6 meter away from the fire stair. Okay,
Clear.
then that has to, they will consider that that has to operate and the floor below. Okay, and each hydrant had 250 gpm of flow. Okay, considered. Now
Yes.
this, if fire is on this floor, then you consider the floor of this what do you call, the GPM of this floor plus the GPM of the floor below it.